வணக்கம், வாழ்க வளமுடன். மேக்ஸ் இஸ் நாட் டிஃபிகல்ட். கணிதம் கடினம் அல்ல. Only thing, you have to practice regularly, write periodical tests, self-evaluation. முயற்சி செய்யுங்க, பயிற்சி செஞ்சா கண்டிப்பா தேர்ச்சி நிச்சயம். Last classல we discuss differential calculus, exercise number 5.1 and 5.2. Already I told you, definitely you will expect one 10-mark question from these two exercises. So that's why whenever you are free, please write test the 10-mark question from exercise number 5.12. After completing the test, self-evaluation, that is very important in mathematics. When you do self-evaluation, you can identify the error yourself. If you identify, definitely you will not repeat the same error in future. So that's why I'm insisting you, self-evaluation is very important. Then the major two exercises already we completed, exercise number 5.1 and 5.2. I think most of the students are comfortable with these two exercises. 5.1, 5.2 exercise முடிச்சிட்டோம். கண்டிப்பா இதை பார்க்கும்போது உங்களுக்கு டிஃபரன்ஷியல் கால்குலஸ்ல இருக்கிற இன்ட்ரெஸ்ட் கண்டிப்பா கூடியிருக்கும். அதனால இதே ட்ரெண்டோட நம்ம அடுத்த எக்ஸசைஸ் போவோமா? அடுத்த எக்ஸசைஸ்ல வந்து ஒரு சின்ன தியரம் படிக்க போறோம். ஸ்மால் தியரம். தட் இஸ் ரோல்ஸ் தியரம். Rolle's theorem, let f of x be a real valued function. Whenever you write any theorem, what is given in the book, same way you have to write. If you change any word, it is not Rolle's theorem, you write some other name theorem. That's why in physics, chemistry, maths, if you write any definition, don't write add your own word. That is very important. So first you have to write about the Rolle's theorem. Let f of x be a real valued function. Be a real valued function. First condition, f of x is continuous on the closed interval a comma b. Second one, f of x is differentiable on the open interval a comma b. Third condition, f of a equal to f of b, such that there exists at least one point C belongs to AB. There exists at least one point C belongs to A comma B. Here open interval only in continuous closed interval, such that f dash of C equal to 0. So first you should know the difference between the open interval and closed interval. What is the closed interval? Closed interval means the value between A and B included A and B. That is A comma B means A less than or equal to X less than or equal to B. If it is open interval A comma B means the value only lies between A and B. That is the major difference. A less than or equal to X less than or equal to B, A less than X less than B. The continuous and differentiable already you studied in 11th standard, exercise number 7.2, that is continuous, 7.3 differentiability. For example, If we consider the sine curve, it is always continuous in all the case, anywhere. Same way, if it is cos x, it is always continuous under differentiability. If we consider the tan x curve look like this way. So here it is discontinuous at x is equal to pi by 2 because tan pi by 2 is infinity. So tan pi by 2 at x is equal to pi by 2, the curve does not exist. Therefore, it is continuous only the closed interval, only in the open interval minus pi by 2 to plus pi by 2. If it is a closed interval, it is not continuous at x is equal to pi by 2. Suppose y is equal to 1 by x. So xy equal to 1, rectangular hyperbola never touches the axis. When we put x is equal to 0, any number by 0 infinity, the curve does not exist at x is equal to 0. Suppose if we consider y equal to 1 by x minus 1, it is not continuous at x is equal to 1. Not continuous at x is equal to 1. So sine cos always continuous, always differentiability in any interval. No need to verify. Same way, if it is a polynomial, any equation, no denominator, any polynomial equation, no denominator, definitely it is continuous and differentiability. Next one, differentiability. In differentiability, the special case. So modulus x. The diagram, it looks like at x is equal to 0. So here y equal to x, here y equal to minus x. R f dash of 0 not equal to L f dash of 0. R f dash of 0 not equal to L f dash of 0. That's why it is not differentiable at x equal to 0. Same way, modulus x minus 1. It starts from 1. It looks like that. This is x minus 1. This is minus x plus 1. At x is equal to 1. R f dash of 1 not equal to L f dash of 1. Left hand side value, right hand side value f dash of 0, 1 value same irukadu. Adanala it is not differentiable at x is equal to 1. So think about whenever modulus, just you have to verify modulus x at x is equal to 0. X minus 1 means at x is equal to 1. Modulus x minus 2 means at x is equal to 2. It is not differentiable. So same way we have to verify the continuity and the differentiability. Then you have to verify the third one. That is f of a equal to f of b. Now shall we go to the exercise? Exercise number 5.3, verify Rolle's theorem of the following function. First question, f of x equal to sin x. X belongs to the closed interval 0, pi. The first one, sin x, already I told sin x, cos x, whatever interval is given, it is a continuous, it is in differentiability. Therefore, first two conditions are satisfied. F of x is continuous on the closed interval 0, pi. Second, when we differentiate sin x, cos x is differentiability in the interval 0, pi. So f of x is differentiable on the open interval, don't write OI, open interval 0, pi. So next we have to verify the third condition, f of a, f of b. Before that, so Rolle's theorem, just I will consider any function, the curve y equal to f of x. So this is a, this is b, this is f of a, f of b, both the length are same, then draw a tangent, select any point, the tangent is parallel to x-axis, any tangent parallel to x-axis, f dash of slope equal to 0. This is the Rolle's theorem, a and b, any point, It is a closed, continuous on the closed interval. Differentiable also exists. F of A, this height, F of B, both are equal. Then take any tangent, C be any point, the tangent parallel to which axis? X axis. Tangent parallel to x axis means f dash of C equal to 0. Third condition, f of 0, sine 0, 0. F of pi, that is sine pi, is also 0. Therefore, f of 0 equal to f of pi. All the conditions are satisfied. All the three conditions, what conditions? Rolle's conditions, satisfied. Then the important line, there exists at least one point C belongs to 0 comma pi such that f dash of C equal to 0. That word is very important. If C is in the interval 0 comma pi, then only we can say that f dash of C equal to 0. Now, first you should know what is f dash of x. F dash of x, sin x differentiation is cos x. So, what is the condition? F dash of C equal to 0. Cos C equal to 0. Already you studied in 11th standard trigonometry solution. Sin theta equal to sin alpha, theta equal to n pi plus minus 1 power n alpha, cos theta equal to cos theta, theta equal to 2n plus or minus alpha, tan theta equal to tan alpha, theta equal to n pi plus alpha. Sin theta 0 na, theta equal to n pi. Cos theta 0 na, enna padichirukkinga nyabapathu parunga. Cos theta equal to 0. Can't able to remember? This general solution, cos theta equal to 0 means theta equal to 2n plus 1 pi by 2. C is equal to 2n plus 1 pi by 2. Put n equal to 0. What is the result? C is equal to pi by 2. So, pi by 2 is in the interval or not? So, therefore, C is equal to pi by 2 belongs to 0 comma pi. So, Rolle's theorem verified at C is equal to pi by 2. Is it clear or not? First one, sin x means no need to verify. This understood. Sin x always continuous, always differentiability in any interval. That's why f of x is continuous on the closed interval 0 comma pi. F of x is differentiable on the open interval 0 comma pi. F of 0 equal to sin 0 equal to 0. F of pi equal to sin pi equal to 0. Therefore, both the values are same. F of 0 equal to f of pi. For all the three Rolle's conditions are satisfied, that is three Rolle's conditions. There exists at least one point C belongs to A comma B such that f dash of C is equal to 0. Now, f dash of x, differentiation of sin x is cos x. F dash of C is equal to 0. Cos C equal to 0, C equal to 2n plus 1 pi by 2. Put n equal to 0 because we have to find out the value of C lies between 0 and pi. When equal to 0, C equal to pi by 2, C equal to pi by 2 belongs to 0 comma pi. So, it is in the interval 0 comma pi, therefore, Rolle's theorem verified that C is equal to pi by 2. Is it clear? Now, I shall go to the second problem, the same exercise. F of x is equal to x square. F of x is equal to x square. So, x square is a polynomial in x. Therefore, f of x is polynomial in x. Polynomial means no need to verify the differentiability and continuity. It is always continuous and differentiable. What is the interval given? 0 less than or equal to x less than or equal to 1 means 0 to 1. X belongs to 0, comma 1. What is the first condition? F of x is continuous on the which interval? Closed interval 0, comma 1. F of x is differentiable in the open interval 0, comma pi. F of 0 equal to 0 square equal to 0. F of 1 equal to 1 square equal to 1. But f of 0 not equal to f of 1. One of the Rolle's condition not satisfied because it is a continuous, it is a differentiable, but f of 0 not equal to f of 1. That's why one of the Rolle's condition not satisfied. One of the Rolle's condition not satisfied. That's why we can't able to verify Rolle's theorem. Stop the problem there itself. Clear? So f of x equal to x square, it is a polynomial in x. That's why these two conditions are satisfied. F of 0 equal to 0 square 0, f of 1 equal to 1 square 1, f of 0 not equal to f of 1. Therefore, one of the Rolle's condition not satisfied. Next, shall we go to the next problem? F of x equal to mod x minus 1. Already I told modulus x minus 1, x belongs to, what is the interval given? Interval is 0, comma 2. Just to draw the diagram for x minus 1, already you studied in 11th standard, x minus 1 means from 1, we draw two lines, here x minus 1, here minus x plus 1. So, interval is given 0 to 2, 0 to 2. From 0 to 2, there is no discontinuity. So, first condition satisfied, f of x is continuous on the closed interval 0, comma 2. But second one, right hand side of 1 r f dash of 0 is plus 1. R f dash of 0 equal to minus 1. Sorry, L f dash of 0. When we differentiate this minus 1. R f dash of 1 not equal to L f dash of 1. Left hand side or right hand side same illa. R f dash of 1, if you find out R f dash of 1, the answer is 1. L f dash of 1, the answer is minus 1. So, both are not equal. Therefore, f of x is not differentiable at x is equal to 1. Therefore, f of x is not differentiable on the open interval 0, comma 2. Second, not differentiable. Third condition, that is f of 0, 0 minus 1 equal to 1. F of 2, that is 2 minus 1 is also 1. Both are satisfied. Even though two conditions are satisfied, it is not differentiable at x equal to 1. One of the Rolle's condition not satisfied. That's why we can't able to verify Rolle's theorem. Listen carefully. Here L f dash of 1 is minus 1. R f dash of 1 is plus 1. That's why it is not differentiable at x is equal to 1. So, one of the Rolle's condition not satisfied. Therefore, we can't able to verify Rolle's theorem. Right here, one of the Rolle's condition not satisfied. The next one, third one, f of x is equal to x cube minus 4x cube minus 9x, x belongs to minus 3 by 2 comma plus 3 by 2. It is a what type of function? Polynomial in x. F of x is polynomial in x. Polynomial means no need to verify. The first condition, f of x is continuous on the closed interval minus 3 by 2 comma 3 by 2. Don't write like that. You have to write f of x is continuous on the closed interval minus 3 by 2 comma 3 by 2. Second condition, f of x is differentiable on the open interval minus 3 by 2 comma 3 by 2. So polynomial in x means it is understood. Continuity and differentiability. Next we have to verify the third condition, f of minus 3 by 2. 4 into minus 3 by 2 cube minus 9 into minus 3 by 2, that is 4 into minus 27 by 8 plus 27 by 2, cancel it 2, that is 0. F of plus 3 by 2, that is 4 into 3 by 2 cube minus 9 into 3 by 2, that is 27 by 2 minus 27 by 2, that equal to 0. So f of minus 3 by 2 value equal to f of plus 3 by 2. Both are same. Therefore, all the Rolle's conditions are satisfied. Therefore, what we have to write? There exists at least one point C belongs to minus 3 by 2 comma 3 by 2 such that f dash of C equal to 0. Now f dash of x. What is f dash of x? 12x square minus 9. But what is the condition? F dash of C equal to 0. 12c square equal minus 9 equal to 0. C square equal to 9 by 12, that is 3 by 4. C is equal to plus or minus root 3 by 2. Root 3 is 1.73 approximately. When we divide by 2, 0.86 etc. So plus 0.86 and minus 0.86 both are lies in the interval. Therefore, C is equal to plus or minus root 3 by 2 belongs to minus 3 by 2 comma 3 by 2 because the interval is minus 1.5 to plus 1.5, but you got the answer minus 3 by 2 minus 0.86 and plus 0.86. So it is a belong in the interval. Therefore, Rolle's theorem, Rolle in third term, C is equal to plus or minus root by 2 will சரிபார்க்கப்பட்டது. தமிழ்ல சொல்லணும்னா f of x என்பது minus 3 by 2 plus 3 by 2 இல் தொடர்ச்சியாகவும் minus 3 by 2 கமா 3 by 2 இல் திறந்த இடைவெளியில் வகையிடத்தக்கதாகவும் உள்ளது. எனவே ரோலின் அனைத்து நிபந்தனைகளும் சரிபார்க்கப்பட்டன. C belongs to minus 3 by 2 comma plus 3 by 2 என்று இருக்குமாறு f dash of C equal to 0. C equal to, எனவே ரோலின் தேற்றம் C equal to plus or minus root 3 by 2 இல் சரிபார்க்கப்பட்டது. மறுபடியும் தமிழ்ல சொல்றேன் பாருங்க. AB என்ற மூடிய இடைவெளியில் தொடர்ச்சியாகவும் A, B என்ற திறந்த இடைவெளியில் வகையிடத்தக்கதாகவும் இருந்தால் f of A equal to f of B. இது மாதிரி மூணு கண்டிஷன் சாட்டிஸ்ஃபை நிபந்தனைகள் சரிபார்க்கப்பட்டால் C belongs to A, B என்று இருக்குமாறு f dash of C equal to 0 ஆகும். அதை பிரதியிடுங்க, ஆன்சர் வந்துரும். Therefore, Rolle's theorem verified at C is equal to plus or minus root 3 by 2. Rolle's theorem C equal to plus or minus root 3 by 2 will சரிபார்க்கப்பட்டது. அழிச்சலாமாப்பா? Last question. Using Rolle's theorem, find the points on the curve y equal to x square plus 1 minus 2 less than or equal to x less than or equal to 2, the tangent parallel to x axis. Y means f of x. F of x equal to x square plus 1 minus 2 comma 2. இதுவும் polynomial in x. F of x is polynomial in x. F of x xின் மீதான ஒரு பல்லுறுப்புக்கோவை. அப்படி இருந்ததுன்னா ஃபர்ஸ்ட் ரெண்டு கண்டிஷன் வெரிஃபை பண்ண தேவையில்லை. இட் இஸ் அண்டர்ஸ்டுட், இட் சாட்டிஸ்ஃபைட். முதல் இரண்டு நிபந்தனைகள் தொடர்ச்சி மற்றும் வகையிடத்தக்கது. அதனால என்ன எழுதுவோம்னா f of x is polynomial in x. F of x is continuous on the closed interval minus 2 comma plus 2. F of x is differentiable on the open interval minus 2 comma 2. Then f of minus 2, that is minus 2 square is 4 plus 1 is 5. F of 2, 4 plus 1 is 5. தமிழ்ல minus 2 comma 2 மூடிய இடைவெளியில் தொடர்ச்சியாகவும் minus 2 comma 2 என்ற திறந்த இடைவெளியில் வகையிடத்தக்கதாகவும் உள்ளது. f of minus 2 4 plus 1 5, f of plus 2 4 plus 1 5. எனவே f of minus 2 equal to f of plus 2. ரூலின் அனைத்து நிபந்தனைகளும் சரிபார்க்கப்பட்டது. All the rules conditions are satisfied. Then there exists at least one point C belongs to A comma B, C belongs to minus 2 comma 2, such that f dash of C equal to 0. Don't put dot dot dot. You have to write. There exists at least one point. C belongs to A comma B. C belongs to minus 2 comma 2 என்று இருக்குமாறு ஏதேனும் ஒரு மதிப்புக்கு f dash of C equal to 0. f dash of C நான் வரும் பாருங்க. Now f dash of x. What is f dash of x? 2x. f dash of C equal to 0 means 2C equal to 0. C equal to 0. C equal to 0 minus 2 comma 2. Therefore, rho C equal to 0. Rule in மாறிலி, rules constant, C equal to 0. C is equal to 0. Therefore, C equal to 0 means x is equal to 0. C equal to 0, rules constant. Substitute x is equal to 0. What is the value of y? That is f of 0. That is 0 square plus 1 equal to 1. Therefore, 0 comma 1 is the point on the curve. The tangent to the curve y equal to x square plus 1 parallel to the x-axis at 0 comma 1. The tangent to the curve parallel to x-axis at 0 comma 1. 0 comma 1 என்ற புள்ளியிடத்து வரையப்படும் தொடுகோடு x அச்சுக்கு இணையாக இருக்கும். y equal to x square plus 1 என்ற வளைவரைக்கு 0, 1 வரையப்படுகின்ற தொடுகோடு x அச்சுக்கு இணையாக இருக்கும். The tangent to the curve y equal to x square plus 1 parallel to x axis at 0, 1. So இந்த மாடல்ல இந்த எக்ஸசைஸ்ல ஏதாவது எக்ஸாம்பிள் சம் இம்பார்ட்டன்ட் இருந்தா மட்டும் just will go through it. Five point 3 பொறுத்தவரை ஒரே ஒரு எக்ஸாம்பிள் பாத்தீங்க. வெரிஃபை example number 5.22 subdivision number 5. Verify Rolle's theorem. F of x is equal to e power sin x. F of x is equal to e power sin x. F of x is equal to e power x sin x. What is the limit given? 0 less than or equal to pi. Once again, e power sin x, it's the f of x is continuous on the closed interval 0 comma pi. F of x is differentiable on the open interval 0 comma pi. Then f of 0 e power 0 e power 0 sin 0 that is sin 0, 0, 0, f of pi, e power pi, sin pi also 0, f of 0 equal to f of pi. All the three Rolle's conditions are satisfied. There exists at least one point C belongs to 0 comma pi such that f dash of C is equal to 0. Now f dash of x, e power x, differentiation of sin x is cos x plus sin x, e power x equal to 0. This is in the form of uv. U into differentiation of v plus v into differentiation of u. That is f dash of x. But what we have to prove? F dash of c equal to 0, find c. So e power c cos c plus sin c equal to 0. That means either e power c equal to 0 or cos c plus sin c equal to 0. E power c equal to 0 means c equal to minus infinity, definitely c equal to minus infinity, not at all possible. Therefore, only condition sin c equal to minus cos c. Therefore, tan c equal to minus 1. C is equal to tan c minus 1 means it lies in second quadrant. In second quadrant, theta is pi minus pi by 4. Pi minus pi by 4 is 3 pi by 4. 3 pi by 4 belongs to 0 comma pi. Therefore, Rolle's theorem verified at c equal to 3 pi by 4. I think we solved all the problems in exercise number 5.3 and some of the example also we solved. Same way you have to try all the problems in the exercise number 5.3 examples. Next, exercise number 5.4. Instead of Rolle's theorem, Lagrange's law, Lagrange's mean value theorem. Lagrange's law. So, Lagrange's law, whenever I study Lagrange's law, approximately most probably like Rolle's theorem, only one condition, no need to verify. For example, I will consider the curve like that. This is A, this is B, y equal to f of x. This is f of A, this is f of B. So, from A to B, f of x is continuous on the closed interval a comma b, f of x is differentiable on the open interval a comma b, but f of A and f of B are not same. Here think about f of A value, here think about f of A value, f of B value, both are not same. If not equal, we can't verify Rolle's theorem, that is Lagrange's law. So, the law, first one, f of x is continuous on the closed interval a comma b. Second one, f of x is differentiable on the open interval a comma b. Then Lagrange's law, there exists at least one point C belongs to a comma b such that f dash of C is equal to f of B minus f of A by B minus A. Listen, in Rolle's condition, f of A and f of B are equal. If we subtract two equal number, it becomes 0. Is it clear? Now, shall we start the exercise? Already I told for continuous and differentiability, what method you followed in exercise number 5.3, same way we have to do in 5.4. So, in 5.4, the first problem, verify Lagrange's law mean, Lagrange's law of mean for the following, law of mean for the following problems. The first one, f of x is equal to 1 minus x square, 1 minus x square. See carefully. It is a what type of function? What is the interval given? 0, 3. X belongs to 0, 3. It is a what type of function? தமிழ்ல சொல்லணும்னா a, b என்ற மூடிய இடைவெளியில் f of x தொடர்ச்சியாகவும் a, b என்ற திறந்த இடைவெளியில் f of x வகையிடத்தக்கதாகவும் உள்ளது. C belongs to a, b என்றிருக்குமாறு ஏதேனும் ஒரு மதிப்புக்கு f dash of c equal to f of b minus f of a by b minus a. That is the Lagrangian இடமதிப்பு தேற்றம். So it is a what type of function? 1 minus x square is a polynomial in x. F of x is polynomial in x. Don't write dot 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 because already I written lot of problems, that's why I put dot. If it is a polynomial x, it is understood f of x is continuous on the closed interval 0, 3. F of x is continuous on the closed interval 0, 3. Second, f of x is differentiable on the open interval 0, 3. F of x is open interval 0, 3. Next, what we have to find out? Two conditions satisfied. Lagrange's law conditions satisfied. Now what we have to write? There exists at least one point, same one point, C belongs to 0, 3 such that f dash of c is equal to f of 3 minus f of 0 by 3 minus 0. That is the formula. Now first you have to find out f dash of x, that is minus 2x. Then f of 3, 1 minus 3 square is minus 8. F of 0, 1 minus 0 square is 1. What is the formula? F dash of c is equal to f of 3 minus f of 0 by 3 minus 0. That is minus 2c is equal to minus 8 minus 1, 3 minus 0 is 3, minus c equal to minus 9 by 3, minus 2c equal to minus 3, c is equal to 3 by 2. It belongs to 0, 3 because 1.5 lies between the interval 0, 3. Therefore, Lagrange's law verified. Lagrange's law verified at a what value? C is equal to 3 by 2. Clear? Lagrangian இடமதிப்பு தேற்றம் C equal to 3 by 2 சரிபார்க்கப்பட்டது. அதுக்கு அடுத்த क्वेश्चन பாருங்க. இங்க क्वेश्चन மட்டும் நான் சேஞ்ச் பண்றேன். f of x is equal to 1 by x. 1, 2. Suppose the interval contains 0, any number by 0 infinity, not continuous, but the interval contains no 0, that's why it is continuous. F of x is continuous in the closed interval 1, 2. F of x is open interval 1, 2. There exists at least one point 1, 2, f of 2 minus f of 1 by 2 minus 1. Now we have to change this part. Is it clear? Here any doubt? F of x is equal to 1 by x, 1, 2. F of x is, no need to write this line. F of x is continuous in the closed interval 1, 2 because f of x equal to 1 by x curve look like this. This is continuous on the closed interval. There is zero discontinuity at 1, 2. This part. So we have to find out f dash of x. Differentiation of 1 by x is minus 1 by x square. Then f of 1 is 1 by 1 is 1. F of 2 is 1 by 2. That is f dash of C, already we have the formula minus 1 by C square, f of 2 values of minus 1 divided by 2 minus 1 is 1, minus 1 by C square equal to minus half, that is C square equal to 2, C is equal to plus or minus root 2. Root 2 means 1.14, 1.414, 1.414 lies in the interval, but plus value lies in the interval, minus value does not belongs to the interval. Therefore, C equal to root 2 belongs to 1 comma 2, but C is equal to minus root 2 does not belongs to 1 comma 2. Therefore, Lagrange's law verified, rightfully Lagrange's law verified at what value? C is equal to root 2. Is this clear? The next one, sum number 3, f of x is equal to f of x is equal to 2x cube plus x square minus x minus 1. The interval is 0 comma 2. Now once again f of x is polynomial in x. Therefore, f of x is continuous on the closed interval 0 comma 2. This open interval 0 comma 2. There exists at least one point C belongs to 0 comma 2. F of 2 minus 0 by 2 minus 0. Now this part only change. This is 0, 0, no? This is also 0. F dash of x. Now 6x square plus 2x minus 1. Power comes front, power minus 1. F of 0, that is minus 1. F of 2, that is 2 cube is 8. 8 into 2 is 16. Plus 4 minus 2 minus 1. That is f of 2 is equal to 17. Now apply the formula f dash of c, that is 6c square plus 2c minus 1 equal to 17 minus of minus 1 plus 1 by 2, 16c square plus 2c minus 1, 18 by 2 is 9, that is 6c square plus 2c minus 10 equal to 0, that is 3c square plus c minus 5 equal to 0. This is the quadratic equation, but you can't able to solve. That's why using the formula c is equal to minus b plus or minus root of b square minus 4ac by 2a. This c different, this c different. Here a value is 1, 3, b value is 1, c is equal to minus 5. Now substitute minus 1 plus or minus root of b square 1 minus 4ac. 4 3s are 12, 12 5s are 60. That is plus 60 by 2. That is minus 1 plus or minus root 61 by 2. 61 means approximately 7.8 something. Minus 1 plus 7.8, 1.8 divided by 2, 0.9. Approximately it belongs to this interval. It belongs to this interval. Therefore, c is equal to minus 1 plus root 61 by 2 belongs to 0 comma 2, but c is equal to minus 1 minus root 61 by 2 does not belongs to 0 comma 2. Therefore, Lagrange's theorem verified at c is equal to minus 1 by 2. So 0 comma 2, but c equal to minus 1 minus root 61 by 2 does not belongs to 0 comma 2. Next, you have to verify. Anybody having doubt? F of x kuduthirukanga, continuous on the closed interval, open interval, Lagrange's law condition satisfied. There exists at least one belongs to 0 comma 2 such that f dash of c is equal to f of 2 minus f of 0 by 2 minus 0, f dash of x, f of 0, f of 2, that is f dash of c, substitute and simplify, minus b pointing it belongs to 0 comma 2, that is not does not belongs to 0 comma 2. Clear? Same way you try the remaining problems. Sum number 2, What are the conditions given? So, we'll see in the next class. So, one more problem I will complete. F of x is equal to, that is fourth one, f of x is equal to x power 2 by 3, that is minus 2 comma 2. Whenever fraction, just power fraction, just you have to verify differentiability carefully. Just I have to differentiate here f dash of x, 2 by 3 x power 2 by 3 minus 1 means minus 1 by 3, that is 2 by 3 x power 1 by 3. The first one, f of x is continuous on the closed interval minus 2 comma 2, but f of x is not differentiable at x is equal to 0. Therefore, f of x is not differentiable on the open interval 0 comma 2. Lagrange's law not verified. Lagrange's law not verified. That's why, sorry, Lagrange's condition not verified. That's why we can't able to solve Lagrange's law. Okay. So, same way you have to try all the problems. So, the remaining part we'll discuss in the next class. Thank you.